All right. Last week we talked about acid, base, and salts. Do you remember? Have you learned this in school yet?
Haven't.
Haven't, Okay, you remember I taught you soluble and insoluble salts?
Yes.
Can you remember who is soluble, who is insoluble? Can remember.
Soluble.
Sorry,
Soluble.
what?
Yes.
Remember, okay. Right now, the reason why we need to know whether it's soluble or insoluble is the method to prepare. So last week I taught you about one method, which is called titration. Okay, did we do the equations already? Where did we stop at? We stopped here only, right?
Yeah.
Okay. So I taught you that if it is a potassium, sodium, or ammonium salt, we use the method called titration. Correct? Okay. So now I'm going to teach you another kind of salt. If it's a soluble salt, okay, if it's soluble, but it's not potassium, sodium, ammonium. Okay. So for example, zinc sulfate. Okay. Is it a soluble or an insoluble salt?
Zinc sulfate.
Mm.
Zinc sulfate is
Are they
soluble.
soluble? Correct now. So I taught you last week. If it's
Yeah.
soluble, then we use acid neutralization. For example, acid and metal, acid and base, acid and carbonate. You remember this part? Can I? Okay. Uh, so we finished already. Okay. So now today we're going to go to the last one. We're going to prepare insoluble salt. Okay. Insoluble salt, the method to prepare is specific. It's called precipitation. Okay, in order to do this, we use a soluble salt plus a soluble salt. Okay, so for example, I want to make barium sulfate. Okay, I want to make barium sulfate. Is barium sulfate soluble or insoluble?
Soluble.
Barium sulfate.
BaSO4.
Yeah,
Insoluble.
insoluble. So when you want to make this insoluble salt, you cannot use acid and base, acid and metal, all that. You must use a different method called precipitation.
Okay.
Precipitation is like this. You take a soluble salt.
Yeah.
So for example, I want to make barium sulfate, right? So I want to make,
Yes.
okay, I know it is insoluble. So what I need to do is I need to find a soluble barium plus a soluble sulfate. Barium, what is soluble?
Barium. Barium chloride.
Barium chloride or barium nitrate? Because all nitrates are soluble. So this is the aqueous solution. Okay, what sulfate is soluble?
Zinc sulfate.
Zinc sulfate is soluble. So the easiest one to use is always to use sodium.
Sodium sulfate.
Why? Yeah, because all sodium is soluble and all nitrate is soluble. So it's the easiest. Okay. When you take this soluble barium nitrate, which has barium ion and nitrate ion swimming around, and you put inside sodium sulfate, which has sodium ion and sulfate ion swimming around. Okay, immediately what happens is barium will go and find sulfate because that is what insoluble salts mean. Right? Insoluble salts means they love each other so much. Okay, so they immediately combine together to form barium sulfate. And because they're insoluble, they form a solid at the bottom. Can you see that?
Yeah.
Okay, now, once you have this, all you need to do is filter it out. So your barium sulfate is on top. This is called residue or filtrate. Your barium sulfate is on top. Is this called residue or sulfate?
Sulfate.
Residue or filtrate?
Oh, filtrate.
No, the one on top is called residue. The one on top, the solid, is called residue. So barium sulfate, because it is the solid, it will become the residue. Okay, do you understand? Then what is this sound here? This is the filtrate. Who is the filtrate? Who is left over?
2Na and O3.
Okay. So sodium nitrate is the filtrate. It's an aqueous solution. So if I want this salt, since it's already solid, all I need to do is rinse with distilled water and then dry them between filter paper. I don't need to do anything else. Okay?
Okay.
Can you understand?
Yes.
Okay? All right. So here I got a few salts for you. Okay, last week we did a few. Today we do a few more, okay? All right. There's three methods. I want you to try and write down the equation. Okay, do the first one first. What is the method and what's your equation to prepare this salt?
Ammonium sulfate.
Okay, write down the method. Send to me when you're done, okay? So Okay, correct. Neutralization. Um, okay. Precipitation. Nutrition. Precipitation. Okay. All right. I'm going to teach you how to write state symbols. So this one is solid, aqueous, aqueous, liquid. Okay, ZiHua? Right. Now for this precipitation, this is aqueous, aqueous, solid, aqueous. So I want to teach you how to write an ionic equation. An ionic equation, you write when there is a change in state or a change from ion to atom, atom to ion. Okay? So in this case, lead, which started out as an aqueous, reacts with chloride, which started out as an aqueous, to become PbCl2, which is now a solid. So this equation like that is a 3-mark question. Can you understand? You get it?
Yep.
So when they ask you ionic equation with state symbols, it's the kind of 3-mark question. Okay, can you write the state symbols and then for everything, and then can you do me ionic equation for D, ionic equation for D, ionic equation for G, and ionic equation for H. Alright, write state symbols for everybody, but write the ionic equation for D, G, and H. Okay? Can you understand?
Yes.
Okay. Do it and then send me a PDF, okay? PDF easier for me to see. Okay. Must bracket, okay? State symbols must bracket, okay? You how again?
Yes.
Mhm. Okay, very good. So if you look at this, we have done preparation of salt. Okay. Now, remember just now I told you about, not just now, last week I told you about crystallization. Do you remember?
Crystallization.
Do you remember crystallization?
Yes.
Okay, so crystallization is basically, okay, you heat until saturated. Okay, you need to know what is the definition of saturated. Zuha, can you tell me the definition of saturated?
The most amount of particles in a given amount of solvent.
Okay, no more solutes, no more solutes can dissolve in the, or maximum amount of solutes in the solvent at a given temperature. Okay. All right. So when you heat it until it's saturated and then you let it cool, it forms crystals. If you heat it until dryness, then it will form powder. When it's crystals, we call it hydrated salts. It's hydrated salts because it has water molecules chemically bonded to it. Okay. So the examples of the two hydrated salts are hydrated copper 2 sulfate and hydrated cobalt 2 chloride. Okay. The number of the water molecules cannot change. Now, let's say I take hydrated copper 2 sulfate. Then I heat it up. Okay. So this is called a hydrated salt. And this hydrated salt is blue. Okay. Now, it will release the water and become anhydrous. Can you see this, Zuma? Okay. Zuma, what are you looking at actually? Where is your screen?
Huh?
Where is the screen?
It's here.
Then why you keep looking down? What are you looking down at? Oh, okay. Then you don't need to see me write one. Okay, anyway, this is anhydrous and anhydrous is white. Okay, if I add water back to the anhydrous, will it change back to hydrated? Yes, right.
If
So
you
this
add
reaction
water.
is, if you add water, it will change back. So
Yes.
this reaction is reversible. And this is also how we test the presence of water. Okay?
Yeah.
So you need to know that this 5H2O is called water of crystallization. The water of crystallization is water molecules present in hydrated salts. Okay? Can you write this down, please?
Okay. Miss, what is the dot actually?
Means it is chemically bonded, but it can be separated. It's still
Okay.
water molecules, but it's chemically bonded.
Okay.
Okay. Now, another one that can do that is cobalt chloride, hydrated also. This one is 6 water. Okay, this one is the hydrated salt. The hydrated salt is blue. When you add water, when you heat it, the hydrated salt is pink. When you heat it up, it becomes blue. So the
This
anhydrous is blue.
is this cobalt chloride?
Yeah, cobalt 2 chloride. So there are two ways in which you can test the presence of water. Can you understand? Oh, you understand?
Yes.
Alright, so this is what it means. Okay, now, okay, so that's the end of that part. The next part, I don't know whether your teacher is going to straight away teach you testing of salts or is she going to teach you periodic table? Do you know?
I think periodic table first.
Periodic table first. Okay. All right, I want you to do this question. Hold on, let me send to you. When will your teacher tell you which one she's going to give you?
I think she just randomly just told us that one time.
Okay. Give me a moment. Okay. I take a screenshot of a question I want you to do. Can you try and do this question? Can you see it? Wait. Okay. Can you see this question?
Yeah.
Okay. You done? Okay. Okay, correct. Good. Okay, so I just sent you a document. Okay, I don't want you to do all. Some of the questions are a bit old-fashioned already. Okay. Can you please do this thing here? Wait, let me find it. Question 6 here. Can you see this? This question here.
Yes.
Can you do this one? This question here. Do this now. Just do this, and this. These three questions.
Okay.
Oh yeah. Okay. You have it right. I just sent you.
Let me see. Yeah. Oh, the 7-2 preparation of salt one.
Yeah.
Oh, save my exam. Sorry. Sorry.
Do this question only, question 6. Okay. Right. So let's see this. Uh, hey, what did you write? Sulfuric acid, zinc oxide plus sulfuric acid, sulfate and water. Okay. Okay, correct. All right. So homework, don't need to finish all of this. Can you just do from page 10 to the calculation one? Okay, page 10 to page 26. Can? ZiHua? 10 to 26, huh? Okay, I see you then. Bye.
Bye bye.
Bye.